In this video, I am going to discuss atomic mass, relative atomic mass, average atomic mass, molecular mass, formula mass, and molar mass. So let's revise the atomic structure. In an atom, there are three subatomic particles, out of which neutrons are neutral, protons are positive, and electrons are negatively charged. Neutrons and protons reside inside the nucleus. That's why combinedly they are known as nucleons, while electrons revolve around the nucleus. Atomic number is the number of protons, though the number of protons are equal to the number of electrons in a neutral atom. But electrons can be exchanged during the chemical reaction. That's why atomic number is considered as the number of protons, that is the identity of an element. Mass number is equal to the number of protons plus number of neutrons, or you can say it is equal to the number of nucleons. Now come to the atomic mass. Atomic mass is the mass of an atom. If I ask you what is the atomic mass of hydrogen, you will promptly answer it is 1. But if I say it is equal to 1.6736 into 10 raised to minus 24 grams, you will be surprised because in periodic table mass of hydrogen is given 1. Mass of an atom is determined relative to the mass of a carbon-12 atom as the standard. And in this system, an atom of carbon-12 is assigned a mass exactly 12.00 atomic mass units, or you can say AMU. And the mass of atoms of other elements are given as relative atomic mass to that of carbon-12. For example, if we want to measure mass of one atom of hydrogen, it is measured relative to the mass of one atom of carbon. So when we compare the mass of one atom of hydrogen with respect to mass of one atom of carbon, it is found to be 1/12 of an atom of carbon. Mass of one atom of carbon is 12 AMU, and when you calculate 1/12 of 12 AMU, 12 will get cancelled out with 12 and you will get 1 AMU. It is the mass of an atom of hydrogen. That's why in periodic table, mass of hydrogen is given 1 AMU, which is relative mass of hydrogen. Atomic mass unit is defined as mass exactly equal to 1/12 of the mass of an atom of carbon. Or you can write 1 AMU is equal to 1/12 of mass of one atom of carbon-12 isotope. Experimentally determined value of mass of an atom of carbon is 1.992648 into 10 raised to minus 23 grams. Now when you place the value of one atom of carbon in this above equation, you will get 1 AMU is equal to 1/12 multiplied by 1.992648 into 10 raised to minus 23 grams. After calculation, you will get 1 AMU is equal to 1.66056 into 10 raised to minus 24 grams. AMU is also known as dalton and it is also known as unified mass. Let's practice a problem based on it. Mass of an atom of oxygen in gram is 26.56896 into 10 raised to minus 24 grams. What is the relative atomic mass of oxygen in U or unified mass? You know, one unified mass is equal to 1.66056 into 10 raised to minus 24 grams. So here grams will get cancelled out with grams. 10 raised to power 24 will get cancelled out with 10 raised to power 24. And on solving this equation, you will get mass of an atom of oxygen is equal to 16U, and it is the relative mass of oxygen. There are many elements which exist as a mixture of more than one isotope. So how do we measure their atomic mass? So let's try to understand what is an isotope. Isotopes are the atoms of same element but having different number of neutrons. As they have different number of nucleons, their mass numbers are also different. For example, hydrogen has 3 isotopes. One is protium, second is deuterium, and third one is tritium. All isotopes have same number of protons and same number of electrons, but they have different number of neutrons. Protium doesn't contain any neutron. Deuterium contains 1 neutron. That's why its mass number is 2. While tritium contains 2 neutrons. That's why its mass number is 3, which is equal to the number of nucleons. So how do we calculate atomic mass of elements having isotopes? In that case, we will use average atomic mass. It is equal to the average of relative atomic masses, and it can be calculated by the summation of relative atomic mass of an isotope multiplied by its percentage abundance divided by 100. Let's practice a problem based on it. Here you have to calculate the average atomic mass of carbon. There are 3 isotopes, carbon 12, carbon 13 and carbon 14. Their atomic masses are given here and their relative abundance in percentage is also given here. We have the formula average atomic mass is equal to atomic mass of carbon 12 isotope multiplied by its percentage abundance plus atomic mass of carbon 13 isotope multiplied by its percentage abundance plus atomic mass of carbon 14 isotope multiplied by its percentage abundance divided by 100. Now place the value in the given formula. Atomic mass of carbon 12 isotope is given 12 and its relative abundance is given 98.892. So here I have placed the value 12 multiplied by 98.892. Similarly, you have to place the values for carbon 13. For carbon 13, atomic mass is given 13.00335 multiplied by its percentage abundance that is given 1.108 plus atomic mass of carbon 14 that is 14.00317. Here I have placed its value. Multiply by its percentage abundance that is equal to 2 into 10 raised to minus 10. After calculating it, you will get 12.01 U and it is the average atomic mass of carbon. In the periodic table, atomic masses mentioned for different elements are actually their average atomic masses. Now come to the molecular mass. Molecular mass is the mass of a molecule. It is equal to the sum of average atomic mass of constituent elements. Let's try to understand it by solving a problem based on it. Calculate the molecular mass of carbon dioxide. Its formula is CO2. Molecular mass of carbon dioxide will be equal to the average mass of carbon plus average mass of oxygen multiplied by 2, as it contains 2 atoms of oxygen. Now place the values in the given formula. Average mass of carbon is 12U and the average mass of oxygen is 16U. When you solve it, you will get 12U plus 32U. On adding them, you will get 44U and it is the molecular mass of carbon dioxide. Now come to the formula mass. Formula mass is the mass of a formula. It is equal to the sum of average atomic masses of the atoms present in the formula. It is similar to the molecular mass, but the only difference is that it is used for the ionic compounds while molecular mass is used for the covalent compounds. So why is the formula mass used for ionic compounds only? Because ionic compounds do not occur as a single molecule. It is the structure of NaCl. Here you can see number of ions are symmetrically arranged in the form of lattice. NaCl doesn't exist as a single molecule of NaCl. It exists as a form of lattice. In sodium chloride crystal, one Na is surrounded by 6 Cl ions and vice versa. That's why we can't use just molecular mass for NaCl. We have to use formula mass for NaCl. Formula mass of NaCl will be equal to the mass of Na plus mass of Cl. Mass of Na is 23U and the mass of Cl is 35.5U. You will get 58.5U and it is the formula mass for NaCl. Now come to the molar mass. Molar mass is the mass of a mole of substance. If the substance is an atom, then it is equal to the gram atomic mass. If the substance is a molecule, then it will be equal to the gram molecular mass. Let's try to understand it by solving a problem based on it. First, calculate the molecular mass of water, that is equal to the average atomic mass of hydrogen multiplied by 2 as there are 2 atoms of hydrogen plus average atomic mass of oxygen. Now place the values in the given formula. So you will get average atomic mass of hydrogen is 1U multiplied by 2 plus 16U, that is the average atomic mass of oxygen. When you solve it, you will get 18U, that is the molecular mass of water. As we just have learned, molar mass of water is equal to the gram molecular mass, as the water is a molecule. So here you just have to replace this U by G. So the molar mass of water will be equal to 18 grams per mole. Gram per mole is the unit of molar mass. That is what we have learned in this video. Atomic mass is the mass of an atom. Relative mass. It is the mass of an atom relative to carbon-12 isotope. Average atomic mass. It is the average of atomic masses of all isotopes. Molecular mass is the mass of a molecule which is equal to the sum of average atomic masses of all constituent atoms present in that molecule. Formula mass is the mass of average atomic masses of all constituent ions present in that formula, and it is used for the ionic compounds. Molar mass is the mass of 1 mole.